Hi guys, welcome back to my project. This is Eric. In this video, I'm going to make a something special comparison. As you know, Raspberry Pi 02W is the cheapest SBC. It works based on Linux-based operating system. The price is just $15. You can have an SBC at this ridiculously low price. Instead, to be sure, it's very slow. So you need to buy a higher version, not this one, to do internet, watch YouTube, and play simple games. Nevertheless, it allows you to install the programs you want and use them universally. On the other hand, as far as I know, this Arduino Portenta H7 is the most expensive MCU on the market. As a microcontroller, users can program specific tasks to create input-output functions. Because this is MCU, the bootloader is very small, and as soon as it's powered on, the program is loaded and executed. So usually, MCU is used for projects that do one thing or do not require complicated OS such as Linux, and SBC is used for more complex projects. First, let's look at the processors of these two devices. Zero has a 1 GHz quad-core 64-bit ARM Cortex-A53 CPU, and for H7, it has a 32-bit Cortex-M7 running at 480 MHz and Cortex-M4 running at 240 MHz. There's a big difference in spec just by looking at this. Actually, this is about Cortex-A series and M series, and they are built for very different purposes. A series is a general purpose processor designed for use in devices such as smartphones and tablets. However, in the case of the A53, it doesn't support non-sequential execution to realize the concept of real core and low power, so the performance is that good. For M, it's designed as a microcontroller for embedded applications. It's the most popular and notable 32-bit microcontroller used in embedded systems in various fields including drones, smart factories, vehicles, aerospace, home appliance, and IoT. So it's designed for applications that value price and power efficiency over performance. Or maybe, depending on the project, you can use MCU or only use SBC. SBC can be advantageous, especially for projects that require performance. It generally has a larger RAM and CPU clock than MCU. For RAM, Zero has a 512MB SDRAM and H7 has only 8MB SDRAM. Of course, they have different roles, so it's natural to have different specifications like this. So what about the price part? SBCs are usually expensive. The reason is that the resources required for an OS like Linux to operate are more than the MCU, which does simple tasks. However, the official price for the Raspberry Pi 02W is only $15. This is really crazy price. You have to buy a microSD card to install OS, but you can still have an SBC for very affordable price. On the other hand, it costs more than $100. In fact, at this price, you can buy a very high performance SBC. Most people don't think this price makes sense, but it's the price. It's called a high-end MCU, but it's still expensive. What about the pinouts? Zero has 40 GPIOs, but with the exception of ground, 3.3 volts and 5 volts, 28 GPIOs are available. On the other hand, 22 GPIOs are available on H7. For H7, more GPIO, ADC, PWM, and I2C are available using Portenta breakout board, but you have to buy it separately. The price is about $50. Everything is expensive. If you still need to control many sensors with only one MCU, I think this is probably the only solution. Also, for Zero, there is no ADC, so if you have a project that requires ADC with the Raspberry Pi Zero, you must purchase a separate ADC board. H7 has 3 16-bit ADCs and 2 12-bit DACs. As a microcontroller, I think everything you need to control the sensors is here. Since these two devices are in very different categories, the comparison itself could be misleading, but let's do some tests just for fun, why not? The first thing to test is the speed of basic arithmetic operations. Let's benchmark with the same source code. I got this source code from Code Project and there's a link in the video description below. Please try it on your system too. Only that part was modified so that the result value is output after each operation. Also works with the C++ code. The left side is the Arduino IDE and the right side is the Raspberry Pi 02W accessed via SSH. For H7, only M7 core is used and my Zero is not overclocked. Let's look at the power consumption while running the benchmark. Since SBCs do more work internally than MCUs, it's not easy to compare power consumption for the same task. Of course, it's true that Zero consumes more power, but it doesn't make a huge difference. Okay, let's jump into the result. I naturally thought the A53 core would show faster calculation speed, but the result was not. They show that the basic arithmetic operation speed of M7 is not slower than that of A53. Slow only on integer division, fast on everything else. Very impressive. Also, this is a simple single task comparison. If the task uses all of the multiple cores, the results can be different. This time, I'm going to test using an application. Let's say we make a system, and let's say there's a special sensor that can collect 512 bytes every 10 milliseconds. The purpose of this project is to wirelessly send the data obtained from the sensor to the workstation. Since the sensor doesn't have a function to send data wirelessly, SBC or MCU must be used. For example, if you need to run it on batteries, you will have to choose MCU most likely. What would be the difference in performance between SBC and MCU if we were to build a system like this? Here's the system I have prepared, transferring a 512 byte array with update data every 10 milliseconds to the workstation. Personally, I prefer using WebSocket when transferring a large amount of data. For H7, I connected an external antenna to make the Wi-Fi connection more seamlessly. Zero works as a WebSocket client with Node.js code. H7 operates as a C++ WebSocket client. You can think of what I'm holding as a workstation. It's just an external monitor and connected to a PC. It works as a WebSocket server and is built with Node.js. Now let's get started. The top one is H7 and the bottom one is Raspberry Pi 02W. You can see how fast the data is coming in with FPS. And this is 50 kilobytes per second if it's 100 FPS. Total byte size shows the total amount of data obtained from clients so far. In the case of total error, it's made to count if a byte of size other than 512 bytes is transferred. My Zero is a little faster, but both devices show similar FPS. In these constrained systems, either has a similar performance. Acquiring data from the MCU is not a problem. When inputting and outputting this data to another place, very careful control is required. On the other hand, SBC, which allows you to have larger buffers, is a very advantageous operation. What if we send data every 1 millisecond instead of 10 milliseconds? Unfortunately, this couldn't be done with H7, but it was possible with my Zero. I was able to send data very quickly and reliably. The size of the data sent at once could also be larger than MCU. At the application level, I think SBC works greater than MCU. Today I compared the cheapest SBC and the most expensive MCU. If there is a problem with my test, please leave it in the comment. There may be something I missed in making this test. Personally, it will be better to do a project with MCU if it needs to be operated with simple tasks and batteries. I think that everything can be handled simply. In the case of a SBC, it will be good to use it when the power is always connected and more powerful works are needed. If you have any interesting ideas, please let me know. I will try for my project. That's it for today. Thanks for watching. See you on the next project.